Hi, everyone. Thank you for joining us today. We'll give it a few minutes here for people to join us in our webinar today. Thank you for registering for the using endothermic and exothermic reactions to start the school year webinar. Just to go over some housekeeping tips for today, I will be sharing a link to a shared Google folder that has a lot of resources that your host Noose has put together. And I'll put that in the chat here in a few minutes so you can have access to those resources. There's sample data, experiments, and other helpful tips in that folder. We'd love to answer questions along the way during the session today. So if you would like to either put your question in the chat feature, or you can also raise your hand and we will try to get all of your questions answered. If we happen to not get to a question, we will definitely follow up afterwards. And just let you know, we are recording this webinar today, so I'll also put the link to where you can find that in the next few days on our website. So I'll put the link to where on our website you can find that later towards the end of the session. Okay, so Noose is a longtime teacher. He has 34 years of experience teaching high school chemistry and physics in Frederick County, Maryland. He has some awards that he has won, and he's been using Vernier equipment and consulting for Vernier since 1984. So he's very well versed in Vernier, all things Vernier. And he has been working at the office with us for the last 5 years. And he does a lot of the trainings that we do. And he's in our chemistry technical support department. So I will pass it over to Noose to go over the agenda for today.
Hi, my name is Hisim. I work in the chemistry group at Vernier. We have 3 of us in the group, and I'm primarily doing high school and middle school activities, particularly that deal with chemistry. And one of the things that happened a number of years ago, as I was trying to find the pictures, I actually found some pictures. There's my students doing this activity in 2006. So I was trying to remember, when did Jack challenged me. So Jack Randall is one of the authors of our chemistry books. And 15 years ago, and maybe a little longer, he challenged me and he said, "Hey, Deuce, what do you think about starting the school year day 1 collecting data?" And I thought, how can I do that? How can I do it safely? And so that's my plan today, is to share this, because I started doing this 15 years ago, and the other people in the department were like, "What are you doing? You haven't even gone over safety yet. You haven't even got the students' names yet. What are you doing?" And I just thought, I got to do something different. So that's exactly what I'm sharing with you guys today. So, the one thought was, what can I do that's useful, something that I could use during the course, but also safe. And so we have an experiment in our first chemistry book, endothermic and exothermic reactions, and that one uses hydrochloric acid and magnesium, and it's a great reaction, but not good for the first day of school. So I modified it a little bit, and I'm going to share those modifications with you. I'm going to show you the setup. I'm going to show you how I start that first day of school. Then we'll collect some data together, and we'll analyze it, and we'll talk about it, and I hope folks will hop in and talk and raise your hand or whatever. I taught 34 years. Biggest class was 38 in my room, and my room, you saw a picture of it. That's a bit of it right there. So I had 6 of those peninsulas, 12 lab stations, but once you gather 38 to 40 kids around those, it gets a little bit on the crowded side. And but anyway, so let's see. Couple of things. Why did I do Vernier? So people ask me over the course of all the years that I consulted while I was teaching, why Vernier, not other companies? It's support from teachers and stuff developed by teachers. So that's always been the case, and that has not changed since I've been in the office. In fact, I've learned some things that about how much the Verniers want to support the education community, especially this last year. So one thing I would suggest, if you want to play along, I set this activity up so that you can play along. So this whole year of COVID, and people having all kinds of different arrangements, wouldn't it be nice? This is a rhetorical question. Wouldn't it be nice if you could do a demonstration and your students could get live data from you? So on any device that you have handy, and I might suggest you do it on a second device, like do it on your phone or do it on something else. Put graphical analysis on there. Just go to the if you're on an iPhone, for example, go to the App Store. If you're on a Chromebook, go to the Google web. What is it called? The Chrome Web Store. The link is there, but it's just go to Vernier and go search for graphical analysis, and you'll find it. The software is free, and so you don't need anything else, just the software. And I'm gonna the way to make it so you can share data is not free, but I'm gonna make it free for you guys today. So the other thing Angie mentioned is I set up a folder of files to share with you guys, and so everything I talk about in the presentation today, you can get. Okay, and I wrote some of the files so that you can modify them, so that to match your needs. So here's the thought. Kids walk into my room day one. What do they do? Well, they come into my classroom and I hand them a playing card, and what happens is that they take the playing card. So here, these are cheap. You can get these like Costco. You can get, like, I don't know, whole bunches of these things. I mean, in boxes. And then what I did was I had 12 lab stations. So you'll notice that there's no king in here because my lab stations went from ace to queen. And kids would take the card, and then on the board I would have directions. Take the card, any card, put your stuff on a table. I had all these tables to sit at in the middle of the room. Find your lab station. So they would bumble around a little bit and be looking at the card going, okay, they figure it out. Because if you notice, at the ends of all my lab stations I had a card, and follow the directions on the card at your lab station. So that's the handout. Let me see if I've already got it up on the screen here. Not that. Yeah, let's see if I had it open earlier today, then I forgot about it. So let me get it open here real quick. And what I did was I laminated these instructions so that they didn't get too messed up. So this file is in your in that shared folder, so you're more than welcome to take it. I have a PDF in there, and I also have a Word file in there and a Google Doc because I don't know what kind of equipment you guys might have. So I sort of wrote a generic version that covers everything. And so you should change this and make it match whatever you have. But so the kids go in, they find their lab station, they put their goggles on, and they follow the directions. So every lab station I've got all the equipment. And so their lab station, this is what my classroom looks like in a different view. My daughter made that quilt for me a number of years ago. But my lab stations, as you can see, each one of them has a playing card taped to the very end of the lab station. And so what we're going to do is we're going to go through, sorry about that, we're going to go through and see how to do this activity. So a couple of things to be aware of. We have some stuff on our website, very handy, and you guys will have this slide deck, and so you can go ahead and look through the stuff on here. We have some remote solutions up there. We're going to talk more about Graphical Analysis Pro here in just a second, and so we'll see how all this stuff works. But let's go back to here, and let me get the camera so you guys can see what my setup looks like. This is not too far off from each lab station. So here is, my lab station, I had one balance for every two lab groups because it was a peninsula. So if you look at the picture, you can see there's a balance right at the end of the table there. And then I told the kids after they sat down, I told them, I treated you really nicely today. So I put all this stuff out so they wouldn't have to bumble around the room too much. They could just get right to work. And so they had everything they needed. But one of the beauties of doing it this way, I found, is you get kids touching lab equipment day one. So they get the feel that, oh, this class is going to be serious. We're going to be doing some serious stuff. And some kids know more, some kids know less. That's fine. the randomized lab groups, that's kind of cool with the cards because, they, unless they're real savvy and try to trade cards with their friends, they usually follow, in my classes, they usually followed the directions and went to their lab group. So let's see how the experiment will work together. You'll follow me along here. I'll have this camera going, and then you're going to get some data as well. So let's take a look at that part of the presentation. So let's get you set up so that you can follow along if you want, okay? And so let me get my copy of Graphical Analysis over here. And if you have a copy of Graphical Analysis already installed, go ahead and launch it. And you may have noticed in the camera view there, that I have an iPad hooked up. That would be like your student. Okay, so you guys are my student today. Okay, and so yeah, if you look at the here, there's the camera. You'll see that there's an iPad right here. This is my iPad. So let's get you guys all set up to collect data, and that way you can get the data from me as I'm doing the experiment. So graphical analysis comes in two flavors. There's a free flavor. You can do this experiment individually at every lab station, but since you guys are all over the place, I thought it'd be kind of fun if you could get the data from me and then we can look at it together and run through the experiment together. But to do that, what you have to do is you have to pay a little bit. Depends on what you measure a little bit, how you measure a little bit, but it's a site license for your school. So you don't pay by seat, you pay by how many students you anticipate will be using the software. So if you have less than 100 students that are going to be using the software, then you pay a certain price. And then if it's more than 100 students, you pay a different price, but it's for your whole school. So it's not individual seats or anything like that. And when you do that, you get a key, and you'll notice that I have it down here in the presentation. And so what you need to do is when you launch graphical analysis on your device, you'll get this screen. And Melissa wanted me to make sure that everyone knew that this number right here in the top left corner, you can see it on both my iPad and on my computer. That's the version that you're running on your device. And so to make your Graphical Analysis Pro, what you need to do is type that key that I have at the bottom of the screen into that box. It says authorize your copy. So if you want to do that right now, I'm doing it on my computer, and I'm going to have to go do it on my iPad here. If I had thought it through, I probably would have done it in advance. So, and then if I did it right, then this should go away and I should have a pro version. And you'll notice it says down here, you have 12 days. So you guys will get the same thing. You'll get 12 days of graphical analysis. Let's see if I can get my iPad to play along here. So what I'm doing is, if you might see it in the iPad window there, DS and then 0. Where's 0? And then E6, and then SU dash, where's a dash number, dash, and a capital H. All right, cross my fingers here and see if I did it right. Okay, invalid key, DS06SU, DS0, oh, there's an E in there. Dang. Figures I'd kill time doing this. Where was that E? Is it after the 0? Everybody managing to get their everyone but B? E 6SU 6SU dash H. All right, this time it'll work. Yay! Okay. All right, so we're ready. Okay, now what we're going to do is let's go take a look at the experiment. Okay, and if you need help, Melissa is running on the side over there, and you can definitely contact her, and she'll try to walk you through it. So my suggestion to you is plug your sensors in. If you have Go Direct sensors, which I'm going to use today, I would not mess with Bluetooth that first day of school. Now, I can't speak from experience because these didn't exist when I was teaching 5 years ago. So we did have a wireless sensor, but I had so many stainless steel temperature probes that's what I used. But that's why I gave you this file to edit. So make it work for you. Whatever the combination of interfaces and sensors, you can adjust the file. But my suggestion is have a cable there with a sensor to plug into or an interface, and just make it simple. Don't that first day of school, you don't want a lot of common weird things going on. Have graphical analysis going, and what happens is that when you do that and you plug a sensor in, the software knows. Right? If you look at this on my screen up here, you'll get it. You'll get this in a second. But if you look at my screen up here, notice it says temperature. I can even turn on a meter here, so it makes it a little bit larger, so people can see you. You guys can see me a little bit better. So you can have a very nice display setup if you want for demonstrations and things like that. But when the sensor is plugged in with a cable, it knows right away. Okay, it tells right away. So it's kind of a nice way to do things. It'll make your life a lot simpler. And so that's let's go ahead and get you guys to where I am here, so that you can play along. So here's how you share through the internet with graphical analysis using the Pro version. Okay, look on my screen up here where I have graphical analysis going. Do you see the TIE fighter up here? From Star Wars. Okay, if I tap on that, okay, then I can start an internet sharing session. Okay, so just watch for a second. Okay, and then you'll have something to do. So I'm going to start an internet sharing session. And what this does is it creates a code. Now let me make it big so you guys can all see it. There's the code, okay? Now, on your end, what you need to do is tap here where it says data sharing. So I'm going to do that on my iPad, okay? And what I need to do is on my iPad, I need to type in that code. So I type that code in TUO, oops, that's not an O, 8EP. Oops, where'd the 8 go? 8EP, there we go. Okay, and then once you have that code typed in, tap on connect. Now check out my screen. Yours should look very, very, very similar. Check it out, temperature, right? It knows, it connected. Bottom left corner, you can see that it's connected through data sharing. Okay, so I'm gonna close this this code. I think probably Melissa's got it. So if anyone doesn't get it, she can probably copy that for you. You can always get it again if one of your students is behind or something like that. It is possible to get that code back. But anyway, we're ready. Okay, so now your students would not do this, but I wanted you guys to be able to play with me today. So, in your classroom, you're not going to do all that. You're just going to, put this all out and have the kids do it. So it says tap sensor, we did all that. Okay, we've got a graph. Oh, we're going to do a chemical change. We're going to do a temperature change. Let me get my my camera back up here so you guys can see. And the first one we're going to do is we're going to do baking soda and vinegar. Right? Baking soda and vinegar. Everybody knows baking soda and vinegar gets hot because it bubbles like crazy, right? Let's make a prediction. Okay, so in graphical analysis, bottom left corner, tap on the little graph tools icon and choose add prediction. And you can do that. So I'm going to do it on my iPad too. Okay. So that's what it looks like on my iPad. You should see something similar to that. Okay. And I volunteer at elementary schools and they see it bubbling and they think, bubbling, it's got to get hot. So depending on your device, you can draw what you think is going to happen. Notice that what I drew does not echo on your screen. Students can make their own prediction, right? They can decide how they want it to look. So it's totally up to them, okay? Once you have something you like, tap where it says save. Okay, so I gotta save it on my iPad here before I lose it. Let me do that. All right, now let's get back to the instructions. So the instructions, first thing it told the students to do after they connected the sensor, it says to make a prediction. Okay, so you draw on the graph, weigh the styrofoam cup. All right, let me put that camera back up here. I'll tell you what, I'll put these side by side so that, all right, we don't need, you guys are seeing it yourselves. You don't need that. Okay, so let's wait. So the beauty of this is that kids are collecting data right there at day one, walk in the door, they're already collecting data, right? So they weigh the styrofoam cup, okay? Then they zero it. So they may or may not know about that, right? Of course, if they left the cup on there when they turned it on, it may automatically zero it. And then add 30 grams of baking soda. Look, they walked in the door. It's been what, 10 minutes since they walked in the door? And maybe not. I mean, I had students before the bell start doing this. They go back to their station. Some were real excited, some were less than excited, but the whole idea is at least they're doing something. They're not waiting for the teacher to hand out textbooks and write the number down and fill out that info card or whatever, method that's used at the first day of school. They're using a scoopula, and they might not. Another place where this was kind of interesting to talk about was, are these chemicals? Baking soda, you have that at your kitchen and in your refrigerator. That's not a chemical. Yeah, come on. It's, Anyway, so it says, weigh out 30 grams, put the cup in a beaker. So on a tray, right? I'm going to get the balance out of the way. Purposely, you want to pick an experiment like this that's going to be a little bit exciting but safe, right? Kids have goggles on, baking soda, vinegar. I'm not too worried about them handling that. Okay, and so here we go. Let's see. It says place the temperature probe in the styrofoam cup. Done. Measure 40 milliliters. Look, they're using a graduated cylinder. They may not know, it depends on, where they, what, if it's a first year, ninth grade class, or, could you do this with a middle school group? I did not do this with AP Chem. I mean, with them, I did some other, we did do a first day activity, but it was not this one. Go ahead.
Hey, Noose.
Yeah.
Can you put the data up next to you're showing the experiment and hide the instructions instead?
Yep, I sure can.
And people want to see the data if they're not able to join. So
they're good. Yeah. Okay.
Yeah.
All right.
Awesome. Thank you.
Is that good? Like that?
Yeah. Well, put it in front of the.
Yeah, it's weird. It's the air server takes over.
That is weird.
I didn't know the air server took over like that.
Yeah.
That's first time I noticed that. So I'll tell you what, I'll put put it like that. Yeah, I'll put it like that. They can see what I'm doing. Okay. Yeah. So I've got my 40 milliliters of vinegar. Let's get that out of the way. And then let's go back. The instructions say start collecting data. Now, watch your screen. If you are sharing with me, watch your screen. I'm going to start collecting data. So here it goes. You should see something happening on your end, no matter where you are in the country. And so we're going to take the stirring rod and we're going to put in the vinegar. Here we go. I want that to happen, by the way. I know it says in the instructions, add the vinegar slowly, but honestly, the kids are going to add the vinegar however they add the vinegar, right? And so you definitely want to have some kind of a, you can get those, these cafeteria trays are great, but you can get those, what are they, baking dishes, the aluminum ones, pretty cheap, a whole lot of them. At the same time, and reuse them, rinse them out and reuse them. I wouldn't bake anything in them after that, but it might be surprising to some kids that this reaction was actually getting cooler, even though it was bubbling, right? There might be some, discrepant event sort of thing, right? Does anybody remember that word from way back when, or that phrase? Discrepant events, right? We got a lot of bubbling going on, but this one's getting colder. The other thing I like about this activity is it's super rich in terms of concepts, right? Think about it. We have an endothermic change here. If you follow along with the procedure, they have to calculate delta T, final minus initial. I promise you, I'm not lying. I had a group of 9th grade students tell me that they can't subtract a larger number from a smaller number. That's not, you don't do that. The negative numbers just didn't make sense to them. Yeah, it really happened. I'm not lying. And so, it's just the kind of but you've got this was a chemical reaction. The next one we're going to do is a solubility. So, so there's a lot of what's the difference between a chemical reaction and not a chemical reaction. I mean, it's a very, very rich activity, yet you're not going to talk about any of that the first day. All you're going to do is collect data and have the students calculate delta T. That's all you're going to have them do. And just the idea that many reactions that involve changes in temperature, you would do similar to this using some sort of a temperature probe. Now you'll notice that I picked the default time, which was 3 minutes, 180 seconds, on purpose. I want this to go simple. I want it to go quickly. I don't want it to be like a drawn out thing where there's all kinds of directions the first day. All of our experiments, including the one that's similar to this one, our endothermic exothermic reactions experiment, give you explicit instructions on how to change that, or to talk about, you can stop data collection anytime you want. You don't have to wait until it, stops on its own. But yeah, it's up to you how you want to do that. I kind of like the idea of just using the defaults on day one and just getting some data and having kids get excited, about that. And, it's not changing anymore. What's going on, and so, I'll get that out of the cup just so that, I can give it a chance to warm up a little bit. And then they do a little analysis. Now, the analysis part, you have to do yourself. Okay, so I'm done with I'm going to slide this window out of the way temporarily. Let me get the iPad back over here. Just so that we can compare what we see. So you guys on your end should see something similar to what's on my iPad. But if you look at the instructions for the experiment, it says data collection stops, click and drag across all the data on the screen. So, but notice that when I do that, it doesn't happen on your end. So you click and drag all the data, right? And you can actually grab the edges and go a little further if you want to do that, and then it says to click and drag, and then go to Graph Tools and probably do a statistics, I would think, right? So go to Graph Tools and view statistics. So notice I'm doing this on my end. Okay. But it's not happening on my iPad. That's because we send out the raw data. Okay, we do not do the analysis through the internet. Give your students something to do so they can get the minimum and maximum. Now, what about a lower group of students? Maybe I did this with a 9th grade special ed class, and I have a modified version of the instructions that just says, click on the beginning of the data, write down that temperature, click on the end of the data, write down that temperature, right? And then have them do it that way. Don't mention statistics. You can modify this. I gave you a Word file and a Google Doc. So you can modify this and make it, work for you. And you can have a version for a lower level class and a version for an upper level class, that it's your call. Okay. Let me rinse the cup because we're about to do this again, but they have to, write down the minimum, maximum, and then they're going to do everything exactly the same, except we're only going to change one variable. Okay, so we're going to do it all exactly the same. Melissa, am I still connected?
Yeah.
Okay, the reason I say that is
everything.
okay, my VPN is just acting goofy right now. So as long as we're still good, I'm not messing with anything on that end. Okay.
Yeah.
But yeah, I'm working from home, and many of us are. And for some reason, my remote connection is acting goofy, but that's okay. As long as you guys are still seeing stuff, I'm not messing with any technology. All right. Okay. So what we're going to do is let's rinse out the cup, or in my case, rather than rinse out the cup just to save time and whatever, I'm just going to get another one. But in the classroom when I did this, I would have just one cup. I mean, they would have to do all the rinsing and cleaning and all that kind of stuff on their own. But for you guys, I'll pull out a new cup and we'll do it from scratch. So I got a nice clean one here. So it says to do everything the same except to use calcium chloride. Huh. So what's calcium chloride? Well, one version of calcium chloride is the stuff you put underneath the cabinet to absorb moisture. Right. There's also calcium chloride. You can buy it for melting ice on sidewalks. Probably not something that's super available in the South, but I used to live in Maryland. We used to be able to get it at the hardware store. Damp red, you probably can get anywhere. I imagine that's available at the grocery store. But the idea here is, why do I do this instead of put out containers of calcium chloride, which of course you could do? Well, this whole idea that everything they touch is a chemical. I used to have a little thing I did with lower level kids, like elementary kids. I say, take your finger and touch something that doesn't have chemistry in it. Right. And so they'd be doing this, like, what can I touch? And I'd say, things like, not fair to touch your neighbor's head. Right. Because that still has chemistry in it now, but yeah, it's really hard. They would say, what about the air? I would say, lick your finger, just your finger, not your neighbor's, and wave it in the air. Does it feel cold? Why does it feel cold? And so, this whole idea that chemistry is everything, and I think there's still a pretty common misconception, especially with younger learners, but maybe with older ones, that if you can buy it in the grocery store, it's not a chemical, because it's not going to hurt you. Chemicals are only things that can hurt you, and that kind of misconception, we use chemicals for just about everything, and so, but as far as the experiment goes, and remember, you're not going to talk about this the first day, but it's something to talk about later. Why did we use 30 grams of each? No, it's not moles. Don't you chemists get all excited and yell at me now. We're not using the equal number of moles. Okay, and I buy that, I agree. But controlled experiment, right? We're just changing one variable here. So I've got my 30 grams of calcium chloride, put that in the beaker. Let's get the temperature probe in there. It'd be nice if the temperature probe was close to the same temperature that it was before. And you could see on my screen, maybe not on yours, the bottom left corner there, it's 24 degrees, and you can see I started at 24.6 the last time, so that's pretty good. Neat thing about graphical analysis is that it automatically saves runs, so you don't have to do anything about storing a run. If you do this on a lab quest, you will have to do that, or if you do it in Logger Pro on a computer, which you can do. I mean, for years I did it on Logger Pro because we had gobs and gobs of that equipment, and you have to store the run so you don't lose it. But the neat thing about lab graphical analysis is runs are automatically stored. So I've got my 40 milliliters of vinegar. So now let me start collecting data. Watch your screen. Here it comes. So there's a little inchworm coming across. Let's put the liquid in, the vinegar. So I didn't make a prediction, did I? Dang. Wouldn't it have been smart? Hey, Deuce, wouldn't it have been smart to make a prediction for this? Yeah, and actually it does have that on the instructions. It says do everything the same. So, it would have been smart if I had followed my own instructions to go and make a predict. Okay, the other one got cold. Maybe this one's going to get hot. So what later on in the course, you can talk about colligative properties if that's something that you teach. You can talk about the fact that the solubility of this is exothermic. If you put that on sidewalk, that as it dissolves, it will warm up a little bit and help dissolve this the ice on the sidewalk. There's various factors as to why you might use this. This stuff on the sidewalk to melt ice, or why they use it. It's very what's the term I'm trying to think of? Not hydrophobic. What's the other one where it absorbs moisture? And so that's the reason why you put it underneath the. Now, hey, Noose, can we see the other one, the first one, so we can compare them? I like to do rhetorical questions. Tap on the y-axis label. Okay, and then you can turn on trial 1. Okay, so if you tap on the y-axis label, now you can compare the two of them. Notice we're comparing one that's running live to the one that we did before. You can also turn things off that you may not be interested in anymore. Like I could turn off the prediction now if I wanted to. So yeah, you can, whenever you want to change runs, then what you would do is you would tap on these axis labels. You could change the colors of runs. If you want to make that hot one look red, you could do that. Oh, wait a minute, I did that backwards, didn't I? That blue was a good color for that one. Let me leave that as blue. Notice though that the changes I'm doing, they don't echo on your end. Okay, if you want to try this stuff, you got to do it on your own. Tap on the y-axis label and try it on your own. So day 1, they walk in the door. That's it, right? They get this graph. Depending on your setup in your classroom, you might have the students print the graph, maybe put a title on it, that kind of thing. But day 1, I don't think I want the students to get too hung up on the perfect lab report or anything like that. I just want them to get the experience of collecting data, maybe doing a small manipulation of the data. Like if they look at yeah, go ahead.
So before you go too much further, we had a great question about viewing both runs simultaneously. Mm-hmm. Can you show them how, if you had wanted to do that from the start of the experiment, where they would enable those runs and making sure that they know that they can just enable them at the beginning and then you could see them come in?
Is that the plot all option?
Yeah, you can have them click plot all, or you can just have them do the little toggle switch. So basically when you start data collection, just have them toggle that, mm-hmm. and then they'll see the data coming in. They'll see any previous data. So right. Yeah, that was a great question.
And that's something you might put in the procedure, right? Like, because once again, I took my procedure from 15 years ago and modified it, but I never used graphical analysis because I didn't have it. So, you might go take one of those files that I put in there and just modify that. And here where it says repeat everything, you might add a line in there that says, turn on both runs, right? Because once you do one, the other one, it kind of hides by default. It hides it. So you might have to do a little exploring and see, like, how am I going to make this so my students can see both runs simultaneously, if that's something that you want them to do. When you're doing statistics, that's another thing to think about. If you want the students to do T2 and T1, if you tap on the graph, it shows you both of them. But, do you want both? You want kids to look at both of them? Then what you can do is turn off the first one if you just want to look at the second one. If same with statistics, if you do the statistics and you have them both turned on, you will get the statistics for both of them. Okay, and notice that all the stuff that I'm doing right here does not echo on your end, right? You got to do it yourself. So if you want to do what I was just doing just now, here's my iPad, then I have to go to my iPad and I have to, turn on statistics, By the way, if you do statistics without selecting a region, then it does everything. If you are doing a different experiment, say you wanted to know, what was the average temperature at the beginning, then what you might do is just highlight just a little bit of it, you can actually grab these and slide them around a little bit. And then if you do the statistics on that, oh, check it out. You can do more than one set of statistics at the same time. Isn't that cool? So this one on the right was all my data, but this one here is only looking at delta X equals 8.5 seconds. So,
Hey, Noose,
yes, go ahead.
can you show people the data table and what it looks like and how to enable it?
Sure. Okay. And so you can do this too. Look at this box of boxes at the top. We call it view options. Tap on there. If you want to see the data table, turn it on. Okay. Now I have my screen a little scrunched up here. So if I unscrunch my screen, it'll look a little bit different. Let's get this air server out of the way. These little handles are neat because you can decide like how much of what you want to show. So they're kind of cool. Hey, wouldn't it be cool to have a meter showing at the same time? Sure, turn the meter on. Okay, and so you could have that going, but be aware that a lot of the stuff that you enable on your end may or may not show up on the student's end. There, if you look back at what I did and compare it to what you're seeing, it's different. And so it's important that you kind of fiddle around with this a little bit. I meant this to be a day one activity, but graphical analysis, you guys have it for 2 weeks. So if you want to fiddle with this and try sending data to your friends or to your students or other teachers, you're welcome to share that code with other teachers if you guys want to think about maybe getting it for next year or something like that. By the way, I did something surreptitiously that you may not have noticed. The three little dots in the top right, there's this thing called presentation. And when you're doing a presentation to a group like your students, you can magnify the screen a little bit, make it a little easier for them to see what you're doing. Particularly, maybe you're doing a demo and all you want is you just want a meter. You don't really care about the graph and stuff. And so you just want to have a big meter on the screen. So you can do that. You can make a nice big fat meter, that stands out and your students can see it a little better. So so that presentation mode, I find that very useful, but particularly when I'm doing demonstrations for teachers. Now there's one other thing that is working now that didn't work before on this button that says video. But before I get to that, does anyone else have any comments, questions, concerns about this first day activity?
I just want to make a quick comment. When you were playing around with all the views and the presentation and stuff, my screen, because I'm following your data sharing session, my screen went totally gray. Oh. And it basically, I guess it disabled all the graph and tables. So if that happened to anyone else out there, just go into that little graph view icon again, view options, and enable the graph, enable what you want. If you're losing the data sharing session, it's pretty obvious that you should see, I don't know, Noose, if you can pull up your iPad view again. And in the lower left-hand corner, you should see your mode says data share. So that's a key thing. So that should be a little green dot. And if that ever goes gray, that means you've lost connection to Noose's session. So just rejoin it. Just go click on that untitled button and new experiment, data sharing, and enter the code again. And then you'll jump right in right where you were. So if that happens, that's your fail safe to get back. But any other questions, comments, please put them in the chat and raise your hand. Love to hear from you.
So I've got a short time left, about 15 minutes or so, and I wanted to show you a couple other things in Graphical Analysis Pro. I hope you found this activity interesting, and I hope to hear from some folks that maybe they're using it, or something similar to it in your classes. Oh, I wanted to mention one more thing, and I didn't get to it here. What am I doing while the kids are collecting data? This is what I'm doing, okay? I put this file in the folder. I'm walking around and I'm getting their first names. So they've been randomly assigned to lab tables in my classroom, and I've got this file on a clipboard. I put this in the shared folder, and I'm going around. So the aces, the deuces, I'm going around and I'm asking the students. Now, most of the time, I would rig it so that only 2 students were in a lab group. So when you're setting up your deck of cards, only put 2 aces in there, and you'll only have 2 kids at the first lab group. It depends on the size of your class. You can actually customize your deck for whatever the size of your class is, and every kid is going to get a card, assuming they all show up the first day. And so you don't have to fill out every group with 3 kids or whatever. You can make an adjustment in your deck of cards. Each deck of card will allow you 4 kids in a lab group. But the other thing was that I'm walking around learning their names, and what's really fun is that the students, when they get a little surprised when I'm walking around and writing their names down, and then when they go sit down at the end, that I actually can call out, probably I would say 60% of the kids, I can pick them out. And so, because they're not anonymous, and it's day 1. It's like the teacher's already started learning our names. Oh no, he's serious about this stuff. So really a kind of a neat way to start learning their names. I don't know what that was. It was something yelled at me here. Okay. I wanted to show you a couple of other things in Graphical Analysis Pro that is not in the free version, and you guys can all try this, but it won't echo from me to you. So I'm going to start a new file. By the way, if you're proud of this, or you want to keep a copy of this, let's say you're the student, teacher did a demo, or I have a friend in New Jersey, a friend I've never met, by the way, teaches AP Chem, and what he was doing was, during hybrid, he had kids at school and kids at home, and they would do the same experiment. The kids at school would do the experiment, they would share the data with their partners at home, and then they were allowed to have a camera, so they could have their phone out, so that the students at home could see what there were, and they all got the same data. So Pro is not limited to the teacher. You can have your students, do the data sharing too. But if you want to save it, go to the thing at the top left that looks like a piece of paper that says untitled. Just like any other file on a computer, you would save or save as, depending on where, and just put that on. If you're on a Chromebook, you're going to put it on, I would suggest you put it on My Drive, your Google Drive. Be careful, Chromebooks love to save stuff to downloads, and that's only local. And we've had numerous teachers call and say, how come my student can't find the file that they saved yesterday? It's because they saved it to the local drive on the Chromebook. They didn't save it to their Google Drive. So be aware of that. iPhone has its own way of doing things. I mean, they're all kind of amusing. Other thing under here to look at is the export option. You can export the graph. You can export a CSV if you like to open the data in Sheets or Excel or even Logger Pro. You can export an older version of the data. AMBL is a previous version of Graphical Analysis. You can export a PDF. So you got various ways that you can get the data out. Maybe you want your students to create a lab report, so they take the data out as either a PNG or a PDF, and then import that into maybe when I was teaching forensic science, my students were using Google slides to do their lab reports. And so they would take data like this and just import it into slides. So you got different ways of exporting. So you might want to explore that. You've got it for a couple of weeks. You can fiddle around with some of those things. I wanted to show you some of the cool built-in stuff that's particularly cool for chemistry. So I'm going to do a new experiment. If you want to follow along after you've saved the file, if you want to save it, do a new experiment. It'll warn you if you haven't saved it, so you can always save it later, or not later, but yeah. But what I wanted to point out to you here is this button that says See Experiments. This button does not work if you have the free version of Graphical Analysis, but if you have the Pro version, like you all do, and you click on here, we have a number of built-in experiments all ready for you to look at, maybe. Melissa, why isn't it not working? I'm going to quit and open a fresh copy. I don't know if I boogered it up by fiddling around with it. Let's see if I can get it to work now. What's going on, Melissa? Any thoughts?
Sorry, I was answering some chats. What's your temperature probe is not connected?
No, I'm not able to show built-in example experiments. All right,
Oh,
let me
maybe
try to.
relaunch GA.
I did. So what I'm going
Oh,
to do is I'm going to try it on my iPad.
oh yeah, do
since,
that for
since I
sure.
have my iPad going, I'm going to go ahead and take it over here, and I'm going to try it on my iPad because I don't know what's going on.
Yeah.
This is one reason to have a little backup. Here's my iPad. I'm going to do the same thing. I'm going to do a new experiment, and I'm going to touch See Experiments. Here we go. So what you'll see in here, I'm guessing my version of graphical analysis is a little wacky, so hopefully yours is not. I can filter by subject. I can look at all of them, or I can just filter by subject. So if I do chemistry here, and I can just look at the chemistry experiments, you can see there's all kinds of built-in. The one that's very, very similar to what you and I just did is this endothermic, exothermic one. So I'm going to grab that one. And what's kind of cool about this is look what Melissa did. She made a bunch of videos and she put them into graphical analysis. So think about the possibilities for you guys. Not only can you use the stuff we gave you, you can also synchronize this, right? So you can take this and synchronize the data to, so this one looks like it starts, the data set starts at 0. No, can't start at 0. Let's see where the data set starts. So Melissa put it in there. Let me see if I can adjust it here. But you can synchronize the data collection to the video so that while the data collection is occurring, let me see if I can find the spot here. Yeah. So you would what you'd normally do is, and you can see how she's kind of got it in fast mode there. You watch this until you get to the point where the data is starting to collect, and it'll say that on the screen here. So I'm going to pause it. This one uses citric acid, a little more complicated, but now it should be collecting data, right, Melissa? Yeah. So what I'm going to do is that time is 23 seconds, and can you see that? Yeah. Oh, let me see if I can adjust the thing. That time is 23 seconds. So I'm going to go up here and set the data to 23 seconds. And then play it synchronized.
Noose, you're doing that backwards. You want the data set time to be 0 seconds and the video time to be 23.
I'm a bonehead.
That's all right.
Oh, actually, it's set to 25. That was pretty close.
Yeah.
All right, there we go. All right. So can I restart that? And what'll happen is the data, if you do it right, the data will actually synchronize to the video. So while the video is running, now this one, this is kind of a little more action when you're doing like a physics video or something, but you can have this. Now you're not limited to just the stuff that we give you. If you noticed in the under the view options menu, there is an option for video in which you can add your own. So if you have a set of data and you've taken a video, you can add video to your data. Maybe you want your students to do a project where they collect data and then they also have a video showing how they collected the data. And so that's something that's built into Graphical Analysis Pro that is not in the free version of Graphical Analysis. So that's something to be aware of that might be of use, particularly this last year. Hopefully we'll never go through that again. But you can imagine that we had a lot of requests for videos that went with data sets, and it was difficult. We came up with the software particularly for that purpose, so that you teachers could do that. Okay, let me go back and look at my presentation again. Let's see. Yeah, you can also, like I said, you can also add your own videos to your own data sets. So it's possible to set this up where you've got your own data in there, and then you can once you've got your own data in there, you can then, let me grab a temperature probe here. your students could take a video of themselves collecting data, and they could import it into their data file. Okay, and that's something that's not in the not in the free version of graphical analysis, but you can import your own data into in there. So those are two of the biggies. The ability to use shared data shared data through the internet. Also the ability to pull up already done, maybe you're an AP Chem, you're doing the molar volume of a gas, you can pull up the shared data and video that we created and include with graphical analysis, or do your own. Okay, and so you can put in your own. Now, the other thing that some people find interesting, when Melissa was telling me, you should mention custom calibrated columns. Pardon me, I said that wrong. Custom columns and formulas. You can fit this up here. You can, when you want to fit a curve with Pro, you may notice that mine here says create a custom fit. I can put in my own function. Which is not something that you can do in the free version. So if you have some kind of an unusual set of data and you want to match a function for that and fit it, you can do that. And you can do the same thing in calculated columns. Some of you might be aware that sometimes you want to be able to massage some data by creating a calculated column, and it's not an unusual thing for people want to do. And so when you're doing a calculated column, you can then add in your own custom expression. So you can see here the option to add in a custom expression. That is not available in the free version of graphical analysis. Having said all that about custom expressions, all of our lab manuals, the Vernier lab manuals, will work with the free version of graphical analysis. So don't feel like you have to have the pro version to do any of the experiments that we've written. If you have your own experiment, you're on your own there. But if you're using a Vernier chemistry with Vernier lab manual, advanced chemistry with Vernier, or AP, all of those experiments will work with the free version of graphical analysis. So I'm a horrible salesman when it comes to that sort of thing, but some people like the ability to put in their own functions, and that's kind of a neat feature. All right, we are down to less than 5 minutes. Is there any burning questions, comments, or concerns that people need answered before the end of the workshop? I did put, and I don't know that I can share it right now because of this weird thing that's going on with my VPN, but I did put some pictures of my students. I'm terrible at taking pictures. Found that out when I was trying to find something to share with you guys. Here, I think I can share it now. Let me get the iPad out of the way. And a couple things to be aware of. We put this at the end of the presentation. If you have any questions at all, you can write. If it's a chemistry related question, Melissa, Elaine, or I will get this email, chemistry@vernier.com. In general, if you have a question about a bad sensor or something, you could write to support@vernier.com. Vernier, one of the things that makes Vernier stand out is if you call Vernier during business hours, you are going to get a human. We're not big into voicemail and things like that. So it's another thing that stands out. I was going to share this last bit. Let me see if it's working now. It wasn't working earlier because of the VPN. This is my classroom. You can see, I apologize for the size of the pictures. This was back in the older days with older Macs, and you might even see an Apple II hiding in there somewhere. But these are kids doing this experiment on the first day of school. So I encourage you to think about that. Can you start school with an experiment that's very authentic, very useful? Think about all the concepts that were covered in this activity, starting with safety. Everybody's wearing a pair of goggles. You just with lab equipment, what's a graduated cylinder, what's a beaker, some techniques. Granted, we didn't go over meniscus and things like that. But, we can talk about that later, but they got their hands on some actual laboratory equipment, collected some data and analyzed the data all in the first day of school. Mr. Hisim, when are we going to get our textbooks? Tomorrow. I'm not too much of a rush, maybe at the end of the period. We had 88-minute periods, and so we had plenty of time to do this kind of thing. If you're in a 48-minute class, I understand that you might just barely be able to squeeze in the activity, but I still think it's very valid and very, very important that students get the idea that your classroom is a place where you're going to study science, and using technology to do it is a way that is very useful. So, any last minute thoughts from anyone? We're going to hang out. And so if you have if everybody wants to hang out and ask a personal question, well, don't ask too many personal questions. Yeah, go ahead.
A lot of people are asking about the cost. Can you pull up the
Sure.
pricing page and all that and how that works?
Graphical analysis?
Yeah, pro. Yeah.
Yeah. So we just updated that recently to talk, because it was a little confusing. The Graphical Analysis Pro is relatively new. And so here is the basic costs. Let me zoom it up just a little bit, make it easier for you all to see. So if you have 100 students using graphical analysis, then it's $99 for your school, the license for your school. If you have over 100 students, then the license, it would be $149, and this is for a year. Okay, and then if you're a college, then it's a little more expensive. One thing to be aware of: what if my students collect data on Graphical Analysis Pro and then we don't get it licensed next year? What happens to the data? Nothing. The data is fine. The data will continue to open. If you used a pro feature like videos, you won't be able to open the video in Graphical Analysis when you revert to the free version, but you will not lose your data. So be aware of that. Or in between, maybe we're right in our first round of license re-ups for teachers. I believe today or tomorrow is when the licenses flip over to the next year, and you'd get a new key. So when you when you buy a license from us, you will get a key like that number that was at the bottom of one of the pages, the presentation, and every year you'll get a new one. Okay, it's the same key for everyone in your school, teachers and students, but it will change yearly. Okay. Any other questions? Can you do that activity with old equipment? Absolutely. You saw my students. They're using, I hate to say it, but there's Lab Pros in there, and they're doing it on Logger Pro. Because in 2006, I might have used it with LabQuests too, because if you notice one of the pictures I had in here, there was some LabQuests, and so I have done it with LabQuests too. This was the original LabQuest that were sitting on a cart. This was my LabQuest cart that we used in our department. But yes, you can do this activity with the brand new stuff. If you do, my suggestion would be the day one, you plug it in with the USB cable that it comes with, if you can, just to make life easier. If your students are using a device that doesn't have USB, you may need to connect the sensors for them before class. Was there a question?
Yeah, talk about how the site licenses work.
So the way it works is that when your school buys a site license, whoever buys the license, like when you buy it, it'll ask you the email of the person that's going to be in charge of the license. And so that person will get the license key. So the license key is that number, let me find it here. That one right there. This is the license key and that was the license key for today. All license keys are unique. So then what happens is that person it could be the secretary, it could be the department chair, whoever, that person shares the license key with the teachers. Teachers share the very same license key with their students. On July 1st of the next year, that license key expires. So what ends up happening, take a look at my copy of Graphical, maybe I can show you my copy of Graphical Analysis. It was acting a little wacky earlier. Notice that it comes up and it says, oh, look, Noose, you got 12 days left. What happens when your license key expires? When your license key expires, I'm going to force mine to expire. Then what happens is when you try to use a pro version, it says, sorry, Charlie, that you have to pay for that. And so you have to then re-enter a key. So what you would do is when you re-up your license after July 1st of 2022, then you would put a new license key in and you're off to the races for another year. Did that answer the question?
Yes, perfect.
Questions about sensors? Like, can you only do temperature probe? It's a rhetorical question. Can you only do temperature probe with Graphical Analysis Pro? Of course not. Next workshop we're planning is gas laws. We're talking about doing gas laws in a jiffy, and I'm talking about all of them, folks. I'm talking about Gay-Lussac, Charles, Avogadro, and Boyle. And we can do data collection with a pressure sensor and a temperature probe connected simultaneously. We can do a titration with a drop counter. You can do anything you can think of. You can mix sensors. So you can use Graphical Analysis Pro with a LabQuest sensor and a GoDirect sensor. I'm not going to do that just because there's a million combos that'll work. But yeah, the next one is going to be gas laws. And then the third one, what was it, Melissa? Was that the one on sports drink and beers law? I think that's what we talked
for
about.
AP Chem. Mm-hmm.
Yeah, for AP Chem, but it's Beers Law, folks. So if you're not an AP Chem teacher, there's still going to be some stuff you could potentially use. And that one, I think we're going to use spectral analysis and a SpectraViz. So that's going to be the third one. We haven't quite set the dates yet. I think we have, but I don't have them handy, so I'm not going to yell them out and tell you the wrong date. But the gas laws one has been very popular. I've been doing it with a lot of local training, not local, but webinars. Teachers have really enjoyed it, and we're going to try different gases. So I'm going to throw it, just like I did with this one, I'm going to throw a little loop in that one. And not only we're going to do Avogadros, equal volumes, different gases, same pressure, temperature, equal number of molecules. We're going to do more than air. We're going to do a couple different gases. I'm going to not tell you which ones, but you might be able to guess.
Hey,
so,
Noose,
yeah.
Some people are asking about different subject areas. So if you give them a quick spiel about all the different resources Vernier has for teachers.
So one thing that you might, in terms of training, we have a section called webinars on our website, and there's, you can find training sessions. This is the one you just sat through. Here's some past ones. So those are could very well be helpful. You can look at the different subjects: physics, chemistry, biology. I think there might even be some engineering and that sort of thing. So these are recordings of previous ones. Under educator training, we also have a big video library, so you can find videos on how to connect a sensor or how to do an experiment under the video library. This one you probably want to do a little filtering, and maybe filter by whatever, like maybe high school, and maybe as you might guess, chemistry is near and dear to me. But you can find ones for life science and that sort of thing. As far as the other thing I highly recommend to teachers, particularly if you haven't use too much Vernier equipment, is to look at our lab manuals. One of the things that I used to hear from teachers all the time when I did a training was, who's got the time, right? Who's got the time? We know that. So we wrote a gobload of lab manuals. I mean, I just wrote, or not just me, Melissa and I and Elaine wrote this food chemistry one. What we've done is we've taken a lot of the work where you have to figure everything out. We've done that for you, and you'll notice it's like every area. We've got, from elementary all the way up through college, we have lab manuals. And when you buy a lab manual from us, you get the electronic files that go with that lab manual. So let me bring up to show you what that looks like. I know I'm running over, folks, so I understand if you have to leave. But here is like the chemistry lab manual. If you open it, this is the advanced chemistry book. You get instructions for every possible way that you could collect data, and you get them in Word format and PDF. So if you want something that you can just print out and use and it's ready to go, and if you want, you can get the Word version so you can change it. I used Brown and LeMay and Zumdahl for AP Chem for years, so I took Vernier's labs and put in my own questions, my own pre-labs. We encourage you to do that. The electronic versions also come with the teacher pages. So it, for every experiment, let's look at, there's a teacher page that talks about the SDS and how to set up the solutions and all that kind of thing. So sample answers. So those two things I think are probably the most important. Look under our teacher training, look at videos, and look at webinars, and then look also at the manuals, the lab manuals, so that you don't have to reinvent the wheel. You can start, I'm sorry, that's product manuals, so that you can start right away. And the other thing to be aware of is we do offer 1-hour training sessions for free. And if you want more than that, then there's a charge. But if you got some new equipment, or maybe you're new to the department and Mr. Smith retired and there's this cupboard full of Vernier equipment, please show me how to use it. We would be absolutely happy to do that for you. So just contact us at support@vernier.com or chemistry@vernier.com and just say, hey, Mr. Smith retired and I found all these pH probes and these drop counters, but I have no idea how to use them. And we'll walk you through how to do that. Does that help?
Yeah, I think that answered a lot of people's questions. That was
Okay.
great. So
well, we're running really late, and I don't want people to feel like they have to stay. Let me stop sharing my screen so it gives a little bit of a idea. We like to hang out until everybody's gone. So, but maybe Angie, do we have to cut this one a little bit because we're already way over? So please don't hesitate to write to us. We love to hear from you. And I'd love to see folks at the next one. I think you'll enjoy the gas law one. I think it's kind of fun. I'm going to be going for absolute zero. Okay, so let's see if I got within 2% the last time I did it. So we'll see. And you guys can do it with me, so we can all go for absolute zero. And I have an award for you to share with you. It's the Avogadro Award if we manage to get to absolute zero. So unless there's anything last second, I think we're probably gonna cut this off. Okay.
yeah, thanks everyone for coming. It was great to see everybody. Thanks for participation. Yep, you'll all get a video email. Angie, would you tell them about what they're going to get in the next few days?
Yes, so you'll get a follow-up email with a link to where you can find the recording of today's session. There'll also be a link or a digital file for the certificate of attendance. A lot of you asked about PD hours. And then we'll let you know about upcoming chemistry webinars. We have a few more that Noose mentioned this summer, so we'll give you lots of great resources. And our list of webinars should be up on our website towards the end of this week. And like Noose and Melissa said, thank you for joining us and spending some time with us. This was a really great session. Bye, everyone.
Bye.